Hello, welcome back to the Renewable Energy Technology course. I am Miro and we continue with the biofuel lecture. We're still at lecture 1, the simple biofuels via natural processes. And we're going to talk today about vegetable oils. This topic deserves a whole lecture of itself, and I have collected actually many slides that could have put together many more. Well, we need to be efficient and we will just make a quick summary of vegetable oils, biodiesel or any other products from vegetable oils for the fuel market. Vegetable oils, that is plant oils, are simply polyglycerides, different combinations of organic molecules in a polyglyceride style, whose purpose naturally is to contain or to store energy and nutrition for the seed of the plant to germinate in next generation. We use this fact that most of that energy in certain plants, certain species actually store that energy in the form of oil, naturally occurring fatty acid. Oils are not exactly the same structure or the same combination of hydrocarbons like fossil oil. They are, first of all, polyglycerides. Second, they actually are fatty acids. But they can be used as they are as a replacement to fossil diesel. Oils are easily extracted by fruits or seeds, whatever, by pressing, a simple mechanical process. Well, then the oil will need to be clarified, maybe filtered somehow because it wouldn't be clean enough. Or at least the solid material, any salts or any other impurities would need to be taken away again, mechanically, simply. There is no need for any chemical processing. But apart from cold pressing, which is the simplest and the best process, for example, cold pressing is the one that preferably should be used for food-grade oil, salad oil. Warm pressing can be used, and it is being used in industrial establishments. High temperature extraction of, first of all, pressing at higher temperature, which helps to extract a higher percentage of oil from the seed, and then solving what's left of the oil with the help of an organic solvent. Typically, well, something like gasoline, for example, can work very fine for extracting ethanol from the crushed seed. If you do that, some kind of purification is necessary. Well, this is mostly what the oil that you buy from shops, which is called refined. It has been warm pressed and then purified chemically to take out all kind of traces of the organic solvent. These are long stories, we don't need to stop there. Let's move further and just a quick reminder here of what are we talking about exactly? Well, these are things that you definitely know very well. The oil palm is maybe the best example, but here in the temperate climate, the sunflower seed, the canola, the rapeseed oil, soybean oil, linseed, hemp are the most common oils that we use. Many other plant species have oils contained in their seeds. Even things that you don't really think of, for example, the grape seeds also contain oil. The maize, corn, also contains oil, not much, 10%, but it is oil. It is actually fatty slightly. All kinds of animal fats have the same structure even if they are solid at normal temperature. All kinds of nuts contain oil in higher or lower percentages. Avocado on certain exotic crops like jojoba, jatropha, which are promises for the future and so on. This is definitely not the best, and it's not the intention that you would be reading this, but please look at it on your own, or maybe you can find this kind of statistics on your own somewhere on the internet. A summary of the most popular oil-containing seeds or fruits. Anything that you definitely know of: linseed, hazelnut, pumpkin seed, coriander, mustard, sesame, sunflower, cocoa, peanut, of course, opium poppy, rapeseed, olives. Would you be using olives for food? Yes. For fuel? Well, possible, but maybe not. Price matters and availability matters. Castor seed, Anything else? What do we have? Brazil nuts. Yes, very, very, very oily. Coconuts, oil palm, and so on and so on. The oil palm is the most oil-containing plant on our planet, naturally occurring one. Just as the statistics for worldwide vegetable oil production, well, the palm oil production has been growing most during the last about 2 decades. And it's been growing almost exponentially. It's not always positive, this type of growth. But, well, production is increasing. It's being used both for fuel and for food. Any kind of cookie, mass-produced, low-price, low-cost cookie, biscuit, anything, cake that you buy from the shop contains enormous amount of palm oil. Soybean is very popular in certain parts of the world. And for example, here in Europe, in the common temperate climate, there are actually other types of oil that are most popular and are being used both for food, for commercial purposes, for technical purposes such as, well, margarine or something like that, or being part of processed food somehow, or cosmetics, and also for fuel. And the summary here of other vegetable oils we can define closer in this graph. For example, it is mostly rapeseed and sunflower oil that are the technical crops for oil production of the temperate climate. Sunflower in southern and eastern Europe, well, olives also, but they're expensive. Rapeseed oil in northern Europe, completely ruling the scenery. Oil palm, very interesting. It's actually a tree originating from Central Africa, now being grown everywhere in the equatorial and subtropical climates. It is a cash crop, and you can grow it quite successfully anywhere in the equatorial climate zone. And it has been grown a lot, actually replacing the original vegetation in enormous areas. Funky fruit that is composed of this type of small fruit parts where both the meat, the flesh of the fruit, and the kernel contains oil. Well, slightly old statistics here, what happens or how the palm oil production has been growing. Maybe you can find a newer version of those. It's not much available, but it still shows the trend. And the trend continues even if there is a kind of a saturation for oil production in the very, very recent years. Indonesia, Malaysia, Southeastern Asia now these days are the major producers of palm oil. Also Thailand, African countries, and Latin American countries. This is just a quick view of how the oil extraction process would look like. This can be applied to all kinds of extraction of oil from seeds. But especially with the palm oil, the process is slightly more complicated. It involves a lot of energy. And you should also be careful with the oil, because if you deal with it at a slightly colder climate, it would freeze, it would solidify. It's not a liquid anymore. It's a margarine. We don't need to stop here. We can move on to the rapeseed plant or canola, colza. This is the scenery that you would be seeing, well, indeed, right now, because I'm speaking to you here in the month of June. Wonderful yellow fields out there. More and more popular all around Europe, including Southern Europe, Eastern Europe, and so on, where canola or the raps plant was not that popular before. It is being used for everything from biodiesel, cosmetics, food processing, and so on, including some purely industrial technical applications. The jatropha plant is the, well, believed to be the solution for tomorrow, especially in arid or semi-arid, warm climate, marginal soil areas. However, we should quickly We'll open a bracket here and discuss what do we do in those areas. If you think that a plant would grow without water, without fertilizer, just anywhere, alas, it's not true. If you would like to produce massive amounts of oil from jatropha, even if it survives several years in a row of drought, even if it can survive any other problem, it would not produce anything unless you irrigate it constantly, unless you fertilize it like any other cash crop. Jatropha by itself is not the answer. It's proper maintenance of the land and proper taking care of the crop that is the answer, unfortunately. And many of the oil plants, they are cash crops and they need to be fertilized and taken care of just like any other crop. So in the end, the investment in terms of efforts, additional products, fossil fuel based maybe, including fuel for the machinery, again fossil fuel based, pesticides, everything is actually quite high. Still, jatropha is more promising, especially for poor production areas, especially in places where optimum production is not possible. It can still grow there. It is toxic and it is not being attacked by animals. They realize very easily that they should not eat this plant. Talking about biodiesel, straight vegetable oils versus biodiesel. Biodiesel is nothing else but chemically processed vegetable oil. And that's how the definition of a straight oil is introduced, or also known as pure plant oil, PPO or SVO. The straight vegetable oil is the raw, actual oil coming from the plant or coming from the cold pressing process. Biodiesel can be produced from all kinds of oils, including animal fats, all kinds of fatty acids actually. Chemical conversion into esters, that's what biodiesel is about. There are also other treatment methods available, physical, chemical, we can call them. The final result can be called in different ways. Generally, it is also a biodiesel. Biodiesel is a chemically processed biological straight oil into something that resembles fossil diesel. That's where the name comes from and shouldn't be confused with anything else. Example of the early days of biodiesel production and very fast capacity growth. We're coming back to that. But let's look at the biodiesel actually. What is it? You can also meet it as rapsmethyl ester or fatty acid methyl ester. Please don't confuse these names with anything else. It is a chemical process of transesterification of a complex triglyceride molecule of the fatty acid by combining them or forcing them to chemically combine with alcohols, most commonly with methanol, the cheapest and the most reactive alcohol. It is necessary for the process to use a catalyst. And alkali are best catalyst, especially sodium or potassium hydroxide. Alkaline solutions, they are the perfect or the most practical catalyst for the transesterification process. What the alcohol does is to break the complex carbon chains here into separate esters produced from the fatty acids, the so-called fatty esters, and with a glycerin molecule, the typical glycerin molecule, as a residue product. The biggest disadvantage, of course, is that this is a chemical step. This is a production step that needs to be done. Of course, biodiesel would be more expensive than the straight vegetable oil. The production development of biodiesel, well, it was developing a lot until commonly the last financial crisis. There is a kind of stagnation since then, but biodiesel is being produced both in Europe and in the US on the other side of the Atlantic, in Asia and so on, and is being used a lot in Europe. You could also use straight vegetable oil as fuel, but let's talk about this. Biodiesel pros and cons, advantages. The whole point of producing biodiesel is that it would be the perfect substitute for the fossil diesel produced from straight oil. Unfortunately, it's not that perfect. It's a very good substitute, but it also suffers from some disadvantages typical also for the straight oil. The properties very close resemble the fossil diesels, but not exactly. It can be used in most types of diesel engines, but some very old engines may suffer from certain parameters, and these are most of all the remnants from the catalyst and the alcohol in the final product. It is possible to produce in small scales and batch processes. However, exactly this is a limiting factor because it might not be so easy to sustain or to keep a proper quality parameter or the same quality throughout ranging batch process. It is definitely much more expensive, and it definitely further away from CO2 neutrality compared to the raw oil. The more process steps we have, the more additional products we use, and all the methanol comes from fossil fuel sources, actually the industrial methanol available, brings our biofuel away or further away from the CO2 neutrality. However, biodiesel can be also produced from fats that are not good enough to be directly used for any purpose. Either refuse fats, animal fats, discarded cooking, recycling oils, and so on and so on. Comparison between straight oil and biodiesel. Well, please read those lines by yourself. I have made the most possible to actually put in text all important issues, not to miss anything. Of course, it's difficult to read now the lines, but please focus on these things on your own. If we would be using straight oil in a diesel engine, and it's definitely possible, I am doing that since 15 years, we have to preheat, first of all, the fuel itself before it reaches the engine. It is much more viscous. It can also freeze at low temperatures. Upgrade of injectors might be possible, so adapting the engine to the fuel might be necessary. Avoid old raw oil. All kinds of vegetable oils, they age very easily. They suffer from direct sunlight. They suffer from high temperatures. Of course, they are very complex organic molecules, and something starts to happen inside the molecule if you keep them for a long time. Those processes can be so detrimental that vegetable oils produce gums or wax that appears inside the vessel. If that would be the tank of your car, you're gone. The cold start is difficult because the raw oils may coke directly on your engine or on the valves, on the injectors and so on the piston rings and so on. Biodiesel is supposed to solve all these issues. Unfortunately, it's not solving all of the problems. It also suffers from aging. It also suffers from very low temperatures. But of course, any other parameter is quite closer to the real diesel fuel than the raw oil. Still, if you treat the raw oil properly, you can use it directly as fuel. And indeed, Rudolf Diesel, the guy who built the first diesel engine and gave his name to it, didn't have proper diesel fuel when he was supposed to run the engine for the first time before the public. It happened on the Paris show. You can read about it on the internet. Diesel knew that the engine is made for heavier hydrocarbons. They are available and they should be used in his engine, but he didn't have the diesel at that time, so he ran his engine on peanut oil. Straight peanut oil. Perfect fuel. Combustion characteristics, whatever you do with the oil, either straight or biodiesel, you don't win anything in terms of immediate pollutants. Even if your fuel is CO2 neutral, it will produce the same vicious pollutants when it's burned, either in an engine or in an open fire, just like the fossil diesel. There are other types of biodiesel production. Instead of transesterification of the fatty acid methyl ester, you could actually do something else. You can hydrogenate or hydrotreat the vegetable oil and produce something that, well, this is a proprietary name, hydrogenated or hydrotreated vegetable oil, something like that, produced or developed by an oil company. You can read about it on your own. There are also other similar processes. The point is that the final result is supposedly better than the typical biodiesel, but we can term it biodiesel again. It is the same target that we have, converting the straight oil into something that better matches the typical diesel fuel. And the developers of this method here, they claim that the hydrogen-treated vegetable oil is much better than biodiesel regarding the matching the parameters of the fossil diesel. The biggest disadvantage, again, very expensive. Very complex hardware. It is not at all possible to produce in small scales. It loses the advantage of universability, if you allow me to say so, or independence of the straight vegetable oil concept. Straight oil you can grow in your farm and you can immediately use in your car. You cannot do that with any kind of complex processed fuel. Vegetable oils are readily produced by nature. Please don't forget that. They can be utilized with minimum conversion and minimum processing steps. They are the most natural and the best biofuel available. And they can be utilized. They are proper fuels for the most or the best performing, the most efficient engines we have, diesels. Veggie oils, however, are first-generation biofuels. Unfortunately, their production is very much dependent, first of all, on good land, and second, on all the practices that are related to any cash crop production. Fertilization, irrigation, high investment of energy, and maintenance of the plant. Straight veggie oils, or pure plant oils, if you want to call them so, can be used directly in engines. However, the engine needs to be converted or adapted to the fuel, and the driver needs to take care of it. Esterified or hydrotreated oils resulting in a biodiesel or any such method are developed with the aim to produce a fuel from the vegetable oil which replaces immediately or as good as possible the fossil diesel in any kind of diesel engine without engine conversion. We will stop here the story about oils. We can talk much more. We will switch immediately with the next section to ethanol. Thank you.